A'udhu billahi minash shaitanir rajim. Bismillahir rahmanir rahim. Assalamu alaikum warahmatullahi wabarakatuh. My dear students, as you know, yesterday we just introduced or learned about the syllabus and couple of things about the paper pattern and also about your papers. And the other teachers were also trying to explain you about your paper 1, 2, 2, 3, like this, whatever you have about the core and extended, or you can say that that's supplement. Yesterday, we just learned about matter and state of matter. Today, we're going to find out more detail and depth knowledge, except their definitions. So, as we know that what is matter, everybody can easily explain and discuss about the matter. That's mentioned here, anything that occupies space and has mass. So that is the simplest definition that you should know about the matter. Second thing here, the states of matter. So we know that the matter can exist in 3 states. Actually, there are 4, but we just gonna discuss here only 3. Okay, maybe you're surprised to hear that the 4th state is the plasma. This is made up of sun. Okay, so you can say that the combination and mixture, but we know go towards that thing only as an information. I just share this thing with you. So the solid, liquid, and gases are the 3 states of matter in which any substance can exist, depending on the condition of temperature and pressure. If you remember, yesterday I just put your focus on these 2 things. These we called as condition. What we call them? Condition. So we also share a couple of, you can say that the examples. One of them, why the water in the form of ice convert into liquid in form of, you can say that as a cold water, then it's again start to boil in the form of vapors, or you can say that as gas or steam. So water convert from solid, liquid, and gas only and only due to change in temperature. Okay, so there are many other, you can say that activities or other conditions that affect on matter. Understand? Now, let's see deeply about this thing. Here in front of you, you can see a chart, okay, or a table. Yes. What that table representing you? First of all, the 3 things that's mentioning here. Yes, you can say that, but it's just to focus here. Now, the first thing about solid. Second is our liquid. And the third state is gas. Very clear and visible condition is about, you can only see and you can observe about the particles, how they are attached with one another. You can see here, when your matter in state of solid, how particles attach and you can say that combine one another or with each other. Not about the bonding, just see the structure, how they form. The structure in front of you, you can see that the particles in solid state are close together. First thing, don't forget about that condition and that structure, how particle exists in that state. In state of solid, for example, you have water, H2O. If this water in the condition of ice, so it's mean the water molecule in that condition or that state, they are tightly bound together. Got it? They are tightly bounded. There are no space. Look, this one, that space you can see, but this space is only when they are combining a minor one, or you can say that no space. First point is clear? Yes. On the basis of that property, we move toward gas to liquid. Here you can see that also close together. Understand? Look, this one, again, they are very close together. But one thing here, that after this point I will gonna tell you, they are again close together. Understand? Got it? Yes. Now, mean to say, in the liquid state, when you have a gas, sorry, when you have a liquid like water, again, if it's in liquid state, yeah, what happened? They are again same condition, close together like solid. Understand? Yes. Now we move from the third state, that is gas. For example, when you again more heat this liquid water, it convert into gas or steam. Okay, now here the property change. We're gonna change the statement. Far apart or far away. Look, one molecule is here, second is here, the distance between them too much. They are not close together. Understand? Yes. This point is clear? Okay. On the basis of that property, we're gonna see the second point here that is also in them. This is about the arrangement. Okay. Now you can easily observe that this state, in solid state, when the particles are present, they are in regular pattern. Look, I draw the line. This is a regular pattern between them. After one another, it's not mean they are making a line up and down. They are making a three-dimensional up, down, right, left, everywhere. Like crystal shape. Understand? Yes, you can see like this one. If a solid you gonna see here, they can form in that way. Okay, a regular pattern between them. Got it? So this is about the solid, how particles are present in that state. Understand? Yes. Any doubt, any question till here? Okay, now move toward the liquids, how the particles are here. You can say that same like the solids, close together, but there are random arrangement. Look, yeah, you can say that a movement, but also not a regular pattern, not in a straight line. Yeah, random ups and downs. Yeah, not arranged. Okay, so maybe one is going zigzag, one is left, right, up, down. They are not in a proper arrangement. We can say that random arrangement. Got it? Okay, so the third thing here, in the gas state, there is again random arrangement like the liquids, but how it different from the solid distance or from the gas liquid, the distance, they are far apart. Yes. Okay, they are not closer to each other. Got it? Easy? Okay, now after that, the most important thing here in this topic, and that is the new thing for you, about the movement of particles. This is very, very important part of today's lesson, movement of particles. Before to discuss about the movement, my dear students, you should know about the arrangement, about the atom, the particles. So when we discuss these things, we should know about the kinetic energy. Okay, what is that? Every matter, everything has energy. We know that different types of energy, K, kinetic, PE, potential energy, like different types of energy, nuclear energy, or you can say that the sound energy, light energy. So every material, every matter has energy. Due to the presence of energy, they do something. They do, in the case of the energy, they perform some other reactions. Okay, when, for example, if you are during a fasting in Ramadan, okay, so in the morning till in the Maghrib, to the Maghrib, you will feel that you're gonna little bit lazy. Why? Whatever you eaten in the morning, it's easily consumed and your energy level goes down. Yeah, and after when you Maghrib eat, then what happened? Again, your energy boost up and you again feel little bit energetic. Yes. Got it? In the same way, how much energy have in the particles or in the matter, it will react according to the energy or according to the state of matter. Understand? Okay, in simple words, we can say that the movement of particles, when they are in the solid state, they only vibrate. Vibrate just like your cell phone. When you put it on a speaker, vibration mode, it will not ring, only vibrate on its position without moving its position. Understand? Without moving from its position, it's only vibrate. This is called vibration. You can't say that any matter, any state of matter like gas, liquid, solids, they are unable to move. No, even a solid, you can see this box, you can see this board, door, chair, table, pen, anything. Even they are not moving, but the particles inside are vibrating, are vibrating. Okay, try to understand this concept of vibration. Why during vibration they didn't change their place? Try to understand this thing. Look, my dear students, for example, that is a ball, or you can say that a particle, it's vibrating. Where it vibrates? It vibrates from left to right, equal distance. Okay, for example, here is a 0. It's moved right side 5 millimeter or 5 nanometer. Again, it's moved 5 millimeter or 5 nanometer towards left. Understand? Here 5 plus, here 5 minus. Total distance? Understand? So during vibration, the particles didn't change their place, but just movement like this, vibration. Okay, actually they are not going to change their position. Okay, so the first thing here about the vibration, the movement in solid, only vibration, and that is very, very minor. Okay, but we can't say that they are immobile. We don't use this word. Okay, they are moving. This movement is a type of vibration in which they never ever change their place. Got it? Maybe up and down, right and left, to and fro from its mean position to free position. Yes. Now, what about the condition or the movement in gas? Move around each other. So here, in the case of gas, the particles are, liquid, the particles are moving around each other. For example, in the center one, it's move and turn again back, move and turn again, up and down, left and right. The movement is present. The movement is present. For example, like a glass of water, you can see that if you add sugar, when dissolved, the down molecules will come up, the hot go down. So it's mean the molecules are moving here. Understand? Yes. So the movement is, when you want to just observe their movement, just take a glass of water, add few drops of ink in it, you will see that the particles were moving. Yeah. Okay. So when you stir, the color is spread everywhere in the glass, in the beaker. Got it? Now, the third thing, that is the third state, that's about our gas, move quickly in all directions. So look here, the reason why they are far apart from each other, and they are the force between the molecule not too strong that hold the molecule together. Understand? Understand? In gaseous state, molecules are far away, so they can easily move anywhere. Look, in solid state, molecules are tightly bounded with each other, close. The close each other is due to they have strong force, strong relation. Okay, like a family. Maybe how much you love your brother or sister, you never gonna love with your cousin. Yeah. So, for example, this relation between a family, brother, sister, mother, father, here the relation between you and your cousins, okay, little bit far away. But here the relation between unknown, You don't know anyone. Okay? Strangers. Got it? So just understand the thing and know the relation and the force between molecules, the particles and atoms. Okay? I'm not just gonna telling you about a matter. We have a specific water only. No, we have any kind of matter. Okay? Yes, even metals, solids, liquids, rocks, gases, molecules, compounds, atoms, ions. If they will have a specific state, they behave according to their properties. Got it? Till here, any question? Okay. The last thing here that is very clear, this about the state symbols. What it's mean? These are the state symbols to represent solid. Okay, for example, when you write liquid, when you write gas, when you write solid, instead of writing the complete word, you have the chemist make it easy to understand and little bit reduce time to writing. Just write the state symbol. Okay, only brackets S. In the case of liquid, you write only L within bracket. And for gas, you just wrote only G within brackets. So these are the state symbols, and that is the representation of the state of a matter. For example, you write an equation in which you write H2O. Okay, and here nobody knows in which state that water is present. So if it is ice, what you will write here? Solid. If it is gas, gas. Yeah. So for liquid, L. Okay, here another state symbol. This is representing here as AQ. Yes. Yeah, I already explained you about this. Yeah.
When you mix water with
very good. When you mix water with something, it make a solution, and the solution is due to water mostly. So we call it as AQ, aqueous solution.
Aqueous means mixed.
Yes, aqueous means aqua, water. Basically, we use that word. Or you can say that we mix this thing with water and we name as aqueous solution. Okay. Till here, any question?
No.
Very easy.
Yes.
Okay, just go back to your textbook. Now, about these, here we almost done everything. All these one. Okay. We learned about the fixed volume. We know about the density. We also learned about a shape. If a solid, no movement, definite shape, definite volume, does not flow. Liquid has a fixed volume, mean to say if you add in a glass, if it's 1 liter, anywhere you move it, it will be 1 liter. Okay. Again, moderate at high temperature to low, and shape, if the shape will change according to the container, flow easily. Gas, no fixed volume, no fixed, you can say that the shape, low density, flow easily. About the fluidity, you know very well, a gas or a liquid, they are able to flow. Okay, from till here, from the beginning, if you have any question, please raise your hand. Yes.
Density means
yeah, how the things are heavy and lighter. This is a property that is D is equal to M over V. Okay, mass over volume. Inshallah, in the next session, we will gonna discuss it. This is in detail. Don't worry. Okay. Now after that, come back again. This slide you can see here. This one is only for yourself. Now I'm gonna share these sheets with you. Just try to fill with yourself. What are the things there? Can you display that?
So these are the methods, right?
You will read the question and you will find the answer easily. Try to solve it right now, everyone. And don't do whatever in your mind, whatever the answer comes, try to solve like in your own answer, own word. But first, read the properly. So what's the question here? So particular diagram for the 3 states of matter. Yes, my dear. And Second thing here, solid, liquid, and gas. Describe the movement of these particles and state symbols. So, what do you understand from the question first? Easily. First, what you need to do? Draw the particle diagram. Particles that are representing how they arrange the particles. Number one. Number two, describe the movement. Their movement is how? Okay, vibrating, random, quick. Okay, and the third thing that you need to mention here, state symbols of each state. Okay, if it is in gaseous state, what should be the state symbol? Liquid state or solid state? What should be the symbols? Okay, everyone, please. You have only 3 minutes. Please don't talk. Okay, my dear students, as you learned about, and you can see that how the particles are in different states of matter. If the distance between them, if they are solid, packed closely, you know very well, closely, far away. Yeah.
Yes, we know.
Arrangement of the particle, regular. The second point, if you remember that I explained. Here random, here again random. About the action between the particles, how the force of attraction. Okay, here it's meaning that very strong. That's the reason they held together each other tightly. Weaker than solids, very weak. Okay, like relation I told you, between, within the family, within the, what you say that the kabila, yeah, but tribe, and with the stranger. Okay. Okay, now movement of particles can be vibrate only from their fixed position. Second thing here, particles can slide past each other in a random motion. So freely in random motion. Volume fixed, change. Shape fixed, take the shape of the container. The last thing is here, wherever it will. Density high, lower than solid, very low. So that is compressibility and diffusion, that we'll learn after that. The last thing here about the diagrams. So you can see this one. It's quite easy to know this one. Okay, now after that, we go back to our screen. Here, we will going to here. No, the topping is going record. Okay, now here the first question in front of you on your screen. 4 statements about the arrangement of particles are given. Here are number 1, particles are packed in a regular arrangement. Listen, give me only 10 minutes, then we will listen, Prakash. Okay, so the first thing, particles are packed regular. Okay, no problem. Okay, guys, please focus here. Statement about the arrangement of particles. Very easy to understand. How the particles are arranged. Here also I gave you the first question with the answer and its explanation. The first statement, particles are packed in a regular arrangement. Yeah?
Yes.
That is the, please Muhammad, focus here. Particles are randomly arranged. Okay. Particles move over each other. Okay. Particles vibrate about fixed points. Yeah, it's telling you this all are
States of
different, they can be exist. Yeah. So what we need to know, first we go down, which statement describe the particle in a solid?
particle.
Now, first question, then the statements. After that, which statement can hold or explain best the solid state of matter? Okay. So here we know that number 1 and number 4. Number 1 and number 4. Why the reason? You can see here the reason. Arranged in a fixed regular pattern, they vibrate about the fixed point. So look this one. Got it?
Yes.
Understand? Now, this just as an example that I share with you. Now, I'm just going to explain you one by one the question. Note the answer. Understand? So, first question here on next slide. You can see. Yeah. So, see this one. The first slide in front of you. Just a minute. Diagram shows the arrangement of particle in 3 states of matter. Okay, just try to understand. Solid carbon dioxide, mean to say the dry ice.
Yes.
This the dry ice, maybe you heard about very well. Sublime to gaseous carbon dioxide, mean to say don't worried about sublime. Inshallah, we will also discuss this word in detail, but first just focus on 2 things. Solid carbon, solid state, convert into gaseous state. Understand?
I get the question.
Yes, just a minute, I will explain again, don't worry. Mean to say solid state convert into gaseous state.
R2P.
Okay, which row describe the initial and final state? Mean to say what will be the starting and what will be the end. Okay.
The answer is B.
Yeah. So what will happen first? Just understand. Solid to gaseous. I'm not gonna tell you the answer. It's up to you. I will hand over you the notes and you will find out. But I just gonna explain you the question in detail. Got it?
Yes.
Everyone got it? Even you know, you can write the answer on your notebook. The question number 8, its answer you can write. After that, we will tell you the answer. Now, next. Now, the question number 3 here, what's mentioning? In which change do the particles move further apart? In which change particles are moved further apart? Mean to say they're gonna change more, or you can say that the distance gonna increase. Gas to liquid or liquid to solid. Mean to say W over X or sorry WY,
No.
WX,
Yes.
WZ, XY and YZ. Okay. If you understand, you can write. Otherwise, leave it and discuss this in detail again. Now, question 4. The diagrams show the cup of tea. Just focus on the screen. This cup of tea, there are the waves, mean to say these are the steam, gas coming out from the cup. Here the liquid, here the gas. Which row describe the water particle in the air above the cup compared with the water particle in the cup? Mean to say, here, what will be the particles are doing as compared to inside the cup? Here, gaseous state, here, liquid state. So, moving faster, close together.
Is it close and moving faster? Is it?
Understand? It's mean A condition telling you moving faster, close together. B condition, moving faster, but not close together.
Yeah,
Understand?
we are talking about the steam. not the
Yes.
water.
Yes.
Oh, okay.
Okay. Got it? These are the pattern. This one is the technique, how they ask you question. So please, my dear students, prepare yourself according to the need of the question paper. Not just read and learn. No. Look how I'm explaining you, how I'm describing the thing. Understand? Now, the next one, question number 5 and 6. Very easy, this one. In which substance are the particles close together and slowly moving past each other? Close together, but also slowly moving.
Water. Water.
It's up to you. You need to find the answer. Okay. Air, ice, steam, and water. So air is a gaseous state. Steam is also a gaseous state. Ice, solid, and water is a liquid state. So you can choose your best answer. Okay. Easy this one. Yeah.
Yes, very easy.
Simplest one. The diagram shows different arrangement of particle in 3 different physical state of substance X. Your substance X, it's present in different 3 states. So which statement about the physical state of substance X is correct? Which one is? Particle in state 1 vibrate about fixed position. This one. That is the state 1 here. Particle 1, state 1 change to state 2 by diffusion. Okay, moving the particle from higher to lower concentration. Okay, state 2 change directly to state 3 by condensation. Okay, number 3, a substance in state 3 has a fixed volume.
Obviously.
Okay, so you need to know all these things. Now, the last question here, that is, an attempt was made to compress a gas and a solid using the apparatus shown. You're gonna press gas and solid, putting pressure on it. Okay. According to temperature, we done about the T and other thing. This is about the pressure. Which substance would be compressed and what is the reason for this? Okay. Understand? Now,
Who would have more? So which substance will be squeezed?
it's up to you. It's asking you A, B, C, and D. Which one is the correct one for you? Okay. Now, about the simple, I make it little bit simple for you. You know very well, we can't compress solid. Yeah? Impossible. So it means the last 2 are incorrect. We just plug out. Plug out means to say, we're not going to read even these 2 because solids are incompressible. This is a solid. We can't compress this, okay? But you need to choose from these 2, okay? So 50% question, I make it easy for you.
Thank you, Mr.
Okay, so you need to find the correct one from here. So till here, my dear students, any question, anything you wanna ask, kindly let me know.
So this will